Welcome back again, class. Thank you for joining me for the rest of 7-1. So yesterday we started graphing very basic exponential functions and determining if their growth and decay and what that percent growth and decay was. Today we're going to dive into more complicated graphing, okay? We're going to end up doing transformations of these functions. Now, the cool thing is the basic transformations of these functions really are the same as every other time we've discussed transformations. And we've discussed it a lot. We've discussed with absolute values, with square roots, with parabolas, with cubics. We've done a lot of transformations. So this should be second nature by now. Now we're still going to be using the same strategy. We're going to be starting with a table. All right? So in this one, we know the basic 2 to the x function. All right, so that's going to be our parent function, our basic function. So 2 to the negative 1 or 2 to the negative 2, we know is 0.25. 2 to the negative 1, we know is 0.5. 2 to the 0, we know is 1. 2 to the first, we know is 2. 2 squared, we know is 4. So we know all of those values for the parent function. But now what do? We need to transform it. We need to take every one of those values and multiply it by 3. So we get 0.75, 1.5, 3, 6, 12. So now remember, now this is just like square roots. When we include the stretches in our table, that means that this is what we're going to plot. We can kind of eliminate that original one, and these are the points we're going to end up plotting. So let's take a look at what this looks like. So we have negative 2 and 0.75, would be somewhere around there. Negative 1 and 1.5, 0, 3, 1, 6, and then 2, 12 is going to be off of our chart. But you can see that our graph is going to look like that. So that is a graph of 3 times 2 to the x. And again, when we make these, I'm allowing us to include the stretch in the table. So that's going to be our legitimate function. Now, let's take a look at the pieces, the questions that we have. So, y-intercept, well, you can either look on the graph or in the table. The y-intercept is going to be at 0, 3. The asymptote, so where is it approaching? Well, it's still approaching that same line of y equals 0. The domain, what x values can we use? Well, that's going to be the same, all real numbers. And then remember the range. So the range is special because it has to be everything greater than 0. All the y values we are seeing are the y values that are greater than 0. And we want to know what's changed from the parent function. So how is this different than the basic y equals 2 to the x? Well, what I notice is the y-intercept changed. Okay, we're used to the y-intercepts being at 1. This time it's at 3. Now you may remember we actually discussed this yesterday. We didn't see it graphically, but you saw it a little bit in last night's worksheet, and now we're emphasizing it again today. The y-intercept is going to be 0a. If there's a multiplier, that multiplier is moving that y-intercept, okay? It's stretching it up so it's intercepting at a different point. All right, let's move on to our next graph. So reflections and compressions. All right, so we're going to start again with our basic parent function. So 3 to the negative 2, is 0.11. 3 to the negative 1, 0.33. 3 to the 0 is 1. 3 to the 1, is 3. 3 to the 2 is 9. All right. And we need to take a look at what's happening now. So now we're taking that, we're multiplying it by negative 0.5. So let's see how that changes this. Now, some of these are going to get to be very small values. So, for example, that 0.11, if we multiply it by negative 0.5, negative 0.05 repeating. Okay, so basically negative 0.06. All right, 0.33 repeating times negative 0.5. You're talking about negative 0.17. 1 times negative 0.5 is just going to be negative 0.5. 3 times negative 0.5 is going to be negative 1.5. And 9 times negative 5 is going to give you negative 4.5. So again, just like before, we're including the stretch in the table. Don't need this anymore. Now some of those values would be just ridiculous to try to plot. So like the negative 1, or especially the negative 2, those are getting really difficult to plot. So I'm going to start at 0, negative 0.5, 1, negative 1.5, 2, negative 4.5. Okay, that negative 1 will be somewhere close. So notice what's happening here. Now this is an interesting shape. So this time notice, it's upside down. Now why is that? Well, hopefully you realize it's because of that reflection. It's because of that negative out front that we have flipped our graph. All right, so let's take a look at those pieces again. So you can look at it graphically or in the table, but the y-intercept is going to be 0, negative 0.5. The asymptote is still that same, y equals 0. Domain is always all real numbers. But now let's look at the range. Look at how the range has changed. All right, we are still starting at 0, but this time we're going down instead of up because of that reflection. So we're getting all the values y being less than 0 this time. Okay, and so we need to think about why has this happened? What's changed with the parent function? Well, the reflection flipped the range from being everything greater to everything less than 0 instead. So that's what that reflection piece did to our graph. It flipped the range. So now we're dealing with negatives instead of positives. All right. So let's keep moving forward. Our next one. So horizontal translations. Okay, so again, we're going to start with our parent function. All right, so 2 to the negative 2 is 0.25. 2 to the negative 1 is 0.5. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. This time we could even include 8 in there. All right, so let's plot our parent function. So negative 2, 0.25, negative 1, 0.5, 0, 1, 1, 2, 2, 4, 3, 8. All right. So now that's not the real function though, because remember, this time we have a shift. All right, so remember, every time we have a stretch, we include that stretch in the table with our parent function. However, this time, notice what's happening. Here, we're shifting left 4. So all those points that I just put, I need to shift over 4 to the left. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So I shift everything over to the left to get my new function. All right, now hopefully you can actually tell I just made a big mistake, something that students can do all the time. What did I do wrong? Well, is that really left 4? And again, we said this so many times, but it's so easy to forget that you're not really going to the left. When you see that negative, that is a right shift. So that is right 4. So again, make sure you're watching yourself very carefully that you are not making that mistake. Everything needs to go to the right 4 when you see that negative there. X shifts oppositely of what you'd expect. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So you should get that. So again, make sure you remember that X shifts in the opposite direction. Very simple mistake to make. All right, now looking at these. So the y-intercept. Now, for the y-intercept for these shifted ones, it can be really difficult to tell. All right, so I'm going to say when you have a shift, because it's altering your y-intercept in a way that makes it very difficult to see, we're not going to be too concerned with that when you have that horizontal shifting. All right, I'm not going to make you calculate that for me. Now the asymptote you should still be able to see. So the asymptote is, excuse me, is still sitting there at the line y equals 0. The domain is all real numbers. And the range is going to be our normal y's that are greater than 0. So you may be wondering what's changed from the parent function. Okay, well, you can see the y-intercept has changed. Okay, so it did shift the y-intercept. It's just shifting it in a way that we're not going to worry about figuring out that exact calculation, okay? So I'm happy if you just know the y-intercept has changed. We're just not going to calculate it because you can't tell it graphically, and we'd have to extend our table, which is just extra work for you to try to do. All right, vertical translations. So this is really working on trying to put everything together. All right, so for translations or shifts, again, we're going to graph the parent function, which means including the stretch, and then shift it accordingly from there. So now this time, I've taken out that extra step, that extra table, okay? Because you can actually type this straight into your calculator. So you can type in 8 times 1/2 to the -2 power. All right, now, Be very careful. Make sure that you're using those parentheses exactly as I have when you're typing these in. Make sure that you get 32. If you don't, then you need to make sure you come and ask for help of how to type this in. All right? So 8 times 1/2 to the negative 1, we're getting 16. 8 times 1/2 to the 0, we're getting 8. 8 times 1/2 to the first is 4. 8 times 1/2 to the 2, we're getting 2. And we can even include 3 in here. So 8 times 1/2 to the 3 will give us 1. And I'm actually going to take this a step further just because so many of these values I'm not going to be able to actually plot. So I'm going to include the next one as well. 4 will get you 0.5. All right, so again, include the stretch in the table, and once you get good at typing it into the calculator, you can jump straight to those stretched values, okay? You don't have to make 3 columns. So let's graph this. And again, these first two are completely off the graph, so I'm not going to be worried about plotting those. But 0, 8, 1, 4, 2, 2, 3, 1, 4.5. So there's our function. All right, now what's happening? See that -7? What is that -7 doing? Well, that -7, once we plot our parent function with the stretch, now we move everything down 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. So look at that beauty. So we have our function graphed now. We did our transformations. Now let's look at each of these values. So y-intercept. Now this one, we can actually tell that it's 0, 1. That is clearly on the graph. So this time, again, even though it's not necessary, I am going to point out, hey, we can read it clearly this time. It is going to be 0, 1. What I'm more interested in is the asymptote. So this asymptote, look at what happened this time. All right, so what happened to my asymptote? Well, it shifted down. Interesting. So this is the first time we've seen that happen. The first time that the asymptote has moved. So domain is all real numbers. And now notice, with that shift in the asymptote, that has also changed our range. It's dropped that range down to now everything being greater than -7. So that's the main thing I want you to see with vertical shifts. It moves the asymptote, and therefore it moves the range. So those are the things I want you to pick up from vertical translations is when you're shifting it up and down, you are actually shifting the range in the vertical asymptote as well. All right, so let's look at this. So concept summary of exponential equations. So what is the domain of all exponential functions? So remember this, every single one of them was always all real numbers. There was no transformation that changed that domain. All right, that domain was always the same. Which transformation affects the asymptote? Well, that was the vertical translation. Remember, that's what can move that asymptote up and down. How does a reflection affect the range? So the reflection flips that to that. So it completely flips its orientation from going up to going down. The vertical shift moves it up or down. It gives it the same shift as the vertical shift itself. And how does the vertical stretch affect the y-intercept? Well, the vertical stretch will stretch it so it intercepts the y right at that same value that it's being stretched by. And again, now, the vertical and the horizontal shifting can have changed that. However, the vertical stretch, that's the one that I want you to understand the most of how it affects the y-intercept. All right, so I apologize that this video got a little bit long, but I thank you for joining me. So please make sure that you get all these notes taken, and then when we come back, we'll be ready for our practice work in class.